Hello everyone, welcome back to our channel. You're listening to Dr.Nazma Sheikh, and this video is about the second part of isomerism, wherein we are going to discuss a few very critical examples which have come in the previous year examinations of class 10 CBSE. And in the part 1 of this isomerism, we discussed about the definition, and we also have discussed one example which is very simple, right? So come on, without any more delay, let's get into the critical and important examples of isomerism. Well, one very familiar type of question which is built around this concept is, how many isomers are possible for so and so molecule? For example, maybe how many isomers are possible for pentane, or how many isomers are possible for hexane? Don't worry, your syllabus doesn't go beyond hexane, so you don't need to worry about it. And also make sure you learn for butane. So the number of isomers for butane, pentane, hexane, how do we know this number of isomers? Is there a formula or a shortcut or something? Literally, there is no formula, guys. Even if you go to your higher standards, you only would have to redesign or arrange the molecule and understand how many isomers are possible. So what shall we do right now is, let us draw the isomers for all these three molecules and let us actually find out how many isomers are possible and let us remember them. Because according to CBSE ka syllabus, if they are asking about isomers of hydrocarbons, they will definitely don't go beyond hexane. Hexane is like ultimate limit in hydrocarbons. Okay. But then if they are talking about functional group containing molecules, that's a different play. We'll talk about it in the next video. Well, let's first deal with butane. But then butane, I guess we have done in the last video. Did we? C4H10. Is C4H10 called as butane? Yes, of course it is called as butane. But how many isomers did we find out for butane in the last class? We have seen two isomers alone, and you also have tried finding more, but you could not because it's not possible. So we have answer for butane. How many? 2 isomers are possible for butane. Are we clear? Now, what about pentane? Let's go with next carbon count, that is pentane. So now what shall we do is, let's get into a fresh page and write the formula of pentane first. I'm drawing a simple molecule of pentane, CH3, CH2, CH2, CH2 and CH3. Okay, this is pentane. But then how many carbons and hydrogens are here? We can count it. We have 5 carbons because you're talking about pent. And of course, the hydrogen count, 3 plus 3, 6, plus 6, 12, C5H12, right? And now, can this pentane be rearranged into any other isomer? How do we know? Listen to this carefully. These are some tricks that you can apply to write isomers of the same molecule. Okay, so now see, in pentane you are having totally 5 carbon atoms arranged in the same straight line, correct? This is your molecule. And now what do you do in order to write isomers for this pentane? Take 4 carbon chain length, 1 2 3 4. Okay, what about the 5th carbon then? Take 5th carbon as a side chain. Okay, where to take the 5th carbon as side chain? Take it anywhere of your choice, maybe on this carbon or in this carbon. I am taking here. Now, totally 12 hydrogens should be there. I used 3 over here already. So I'm having 9 more hydrogens which have to be distributed to these 4 carbon atoms which are left. I told you in the last class itself that you should not compromise on the valency. You should satisfy valency of all the carbons and hydrogens. So going according to the same rule, CH3, CH3, because there are already 2 bonds here, 2 hydrogens given to this carbon. There are 3 bonds here, 1 hydrogen given. So quickly count, how many carbons do you have? 1, 2, 3, 4 and 5. I have 5 carbons. How many hydrogens do you have? 3 plus 3 plus 3, 9 plus 2. 9 plus 2 is 11, and here is 12. C5H12, there we go. It's again a pentane. The structure, the molecular formula says it's pentane. So yeah, this can be an isomer of pentane, but how do we name it? That's up to you now, because you have watched the videos of IUPSC already. Did you apply the same rules and tell me the name? If you are trying to do so, and if you have got your answer as 2-methyl-butane, your answer is right. This is 2-methyl-butane. So there are 4 carbons in a row, so you call it as butane. But then on second carbon, you are having methyl group, 2-methyl-butane. So what is the first structure then? Array, it is just a simple pentane, nothing else. You call it as N-pentane. N refers to something which is present in straight chain like this. So N-pentane, 2-methyl-butane, 2 isomers. But then, is there a way that I can still rearrange it? Let's try. But how? I told you that you just have to try if you can reduce on this long chain length. Previously you had 5, you made it to 4. Now, can you now make it to 3 and see? Okay, 1, 2, 3. I believe you are all practicing along with me. Only then you're going to understand. Okay, if you're just listening to me like a RJ or something, this is not going to get into your head. Quickly take a pen and paper, practice along with me. So now the carbon chain length I have reduced to 3. How many more carbons are left behind? 2 more. So where should I attach them to? If I attach them to this carbon and this carbon, doesn't make any sense. It does not. Why? See, they are in continuity if you do so. So you should not. If they are in continuity, what happens? Array, the continuous long chain, you're writing pentane again, right? So don't do this. Then what else to do? Okay, I'll show you. Yes, 3 carbons. You have 2 more carbons left behind. So I can't take that side chain on these 2 carbons because it gives me the same molecule as I have had before. So try to take it on the central carbon now. CH3, okay. Now I have taken one on central carbon. Is it fine if I take other over here on the edge carbon? Okay, I'll show you if it is okay or not, okay? Just be there. Observe the long chain. This is the long chain. How many carbons do you have? 1, 2, 3, 4. So it's butane. Now on the second carbon, what do you have? Methyl. And just you have changed the orientation. The molecule is again 2-methyl butane. Are you understanding? So what do I mean out of all this is you shouldn't write the same things again and again. Okay. So the second substituent have to be here. Now I already have consumed 6 hydrogens and I'm having 6 more. So to satisfy the valency, place them here. Then what about this carbon? It already has 4 bonds and its capacity is only 4, right? So relax. Now can you name this molecule? How would you name it? Simple. 3 carbons in a row. So it has to be what? It has to be propane because single bonds. But then observe this carefully. 1, 2, 3. On second carbon, you have 1 methyl group. But again on the same second carbon, you have second methyl group also, right? Then how do you write it? You have to write it carefully. Somebody asked me a doubt regarding this also in the comment section of my previous video. So it is propane, no doubt about this. But then on second carbon, you have 1 methyl. But again on second carbon, you have second methyl. So you have to write it as 2, 2. The position of both the methyl groups, 2, 2. Di means 2. What is that 2? Methyl, dimethyl. 2, 2 dimethyl propane is the actual name. So if you're getting confused that would we have to write the name in the same pattern? No, that is due to just space constraint. You can write it in a straight line. Okay. So 2, 2 dimethyl propane is the name of this molecule. But then I quickly want you to check if this is isomer of pentane. But how do you check? Array, identify the formula. 1, 2, 3, 4, 5 carbons. Yes. How about hydrogens? 4 3s are 12. Yes, it is. It is an isomer of propane. Isomer of pentane, not propane. Fine. So these are 3 isomers. Something wrong. 3 isomers. Other than these 3, is there a way that you can show up one more isomer of pentane? Can you show one more isomer? You try. Try reducing the carbon chain length. Or try rearranging the atoms in your way, in your own way, but follow the rules. What are the rules? Rule 1, carbon's valency should be satisfied. Rule 2, hydrogen's valency also should be satisfied. So how many? Of course, it's not possible anymore. So how many isomers are possible for pentane according to our research now? The number of isomers possible for pentane is 3. So let's quickly go back and represent it here because we are making a list, right? So pentane can have 3 isomers. Okay. Now coming to hexane. Guys, this you are going to do. Okay. So now let's take a fresh page and we are talking about hexane. Okay. I'll draw the first structure for all of you, but you have to do it. You have to work on your own so that you will understand if you have understood this or not. Okay. So CH3, CH2, CH2, again CH2. Again CH2, last CH3. Is this hexane? Yes, this is hexane. Find out the molecular formula of hexane. Simple, 6 carbon atoms are anyways there. But number of hydrogens is important. It has 3 plus 3, 6 hydrogens, plus 4, 10 hydrogens, plus again 4, 14 hydrogens, C6H14. And now quickly try the isomers. I'll be instructing you, but you have to try along with me, okay? So now in the first molecule, you have taken all 6 carbons in the same line. So in the second molecule, try to take only 5 carbons in a row. 1, 2, 3, 4, 5. Okay? Now what about 6 carbon? Then take it as side chain. Where? Your choice. But please don't take it on the last carbon. Why? If you take here, what difference are you making? Yeah? So don't take here. So remove this place. You can take it on any other carbon of your choice other than the terminal carbons. So I am taking here. Now satisfy valencies. I hope you are following my instructions. And you are also practicing along with me. Only then you're going to learn. Now, yeah, somehow. But then can you please try to name this molecule? 5 carbons in a row. So it obviously got to be pentane. But then which pentane is this? Methyl group on second carbon. So this is 2-methyl pentane. Correct? So this is 2-methyl pentane. This is an isomer, isn't it? But how do we know if this is an isomer? Right, count the carbons. There are 6 carbons. What about hydrogens? 3 plus 3 plus 3, 9. Plus 2, 11. Plus 2 more, 13. Plus 1, 14. So, yes. You have to be verifying always if your isomers are having same molecular formula or not. Okay? They should have same molecular formula. If not, your isomers are wrong. Now you try. Reduce carbon chain length by 1 more. Okay? So this time you had 5 pentane. Now make it into butane. 4. 1, 2, 3, 4. What about remaining 2 carbons? Take them as 2 side chains. 1 and 2. Cool. Satisfy the valencies then. See, if you're stuck anywhere, please make sure you go back, play the previous video, and also watch this video from beginning and practice. This is very important question and also a little critical because this is not explained in NCERT, but still it is asked in your board exams. Okay? Now, yes, observe. 4 carbon atoms in a row. So it is butane, but then look at the substituents. It is butane, but on second and on third, on 2 and on 3, you are having methyl group. How many methyl groups? 2. On second and third positions collectively, you have 2 methyl groups. 2, 3 dimethyl butane. Is this an isomer? Now it's on you. You have to verify. Quickly verify. Is this? If your answer is yes, yes, you're right. Okay. Now I have one question. So in this 2, 3 dimethyl butane, it's nice. You have had 4 so and so. What? 4 what is that? Long, continuous, long chain. Yeah. Now, in this 4 carbon chain length, you are having a substituent on second, and you are also having a substituent on third carbon atoms. But is it necessary that you should have this way? Not really, right? You can also have it in another way. What is that another way? I'm writing it here, you observe, okay? So in spite of having it on different carbon atoms, why don't you have it on same carbon? What is fault? No fault. You can have it, absolutely you can have it as long as the valencies are satisfied. You check for this molecule. 1, 2, 3, 4, 5, 6. 6 carbons. How many hydrogens? 9 hydrogens. Plus 2 plus 3. How much? 9 plus 2 is... Ray, quick. Be a little quick. It's 14, isn't it? So C6H14. Yeah, this is also isomer. Then how do you name this? Choda sa modification. It is butane, no doubt. But on second carbon atom, you have 2 methyl groups. So it will be 2, 2 dimethyl butane. Yeah? I believe you are all able to follow, my dear students. But in case you are lost, please make sure you go back and replay the video. Yeah? So this is another isotope. Another isotope of what? Hexane. In the same way, you just observe this molecule. Okay? 2-methyl pentane. Observe this carefully. I'm erasing the name. You remember it. I'm also erasing this particular thing. I need space here. So in spite of having substituent at second carbon, why can't I have it at the third carbon? I can have. No hassles. We can absolutely have. Then what would you name this as? I would name it as 3-methyl pentane. Okay. Are you all able to follow? Good. Take a look at this. So now how do I know if this is right isomer or not? Very simple. Just I identify the number of carbons and number of hydrogens. It should be equal to this. Yeah. So far how many isomers did we find? We have found isomer 1, isomer 2, isomer 3, isomer 4, isomer 5. Is there anything else possible? You try. You try now. Is there anything else possible? Anything else possible? No, nothing else is possible. If you are assuming to have this 2 methyl groups at this carbon atom, right hand C. According to rules of IUPAC nomenclature, when you have substituent at this carbon atom, you will start numbering from left hand side to right hand side. Then it will again become 2, 2 dimethyl only. So ultimately, this is the count of isomers that you can have for hexane. How many? 1, 2, 3, 4, and 5. So let's go back and place it in the list then. There are how many isomers possible? 5 isomers possible. Okay. So this is the count of isomers for butane, pentane, and hexane. And these 3 molecules are super important. If you really don't want to miss marks for isomerism related questions, you should know this. Okay. Now, is this what is covered in isomerism of your class 10 CBSE? No. You also need to know a few more points. Like, what about the isomerism of the molecules containing functional groups, which we'll be doing in the next class. By the way, guys, in case you want more this kind of videos in more topics, or you have any particular doubt that you want me to record a video on, don't forget to mention it in the comment section. And also subscribe to my channel so that you don't miss an update next time. Yeah. And like the video if you understand what am I teaching to you. I'll see you all soon in the third part of isomerism, wherein we are going to talk about isomerism of the molecules containing functional group, which also is important. Other than these 3 molecules, if anything else has to be asked in exam, it will be chloropentane, chlorobutane, chloropropane, or chlorohexane. Okay, so those molecules we are covering in the next video. So I'll see you all soon. Until then, keep learning. Bye bye everyone.